All right, so the first few questions we're going to take a look at are evaluating trig functions. And we want to do these ones as an exact answer. All right, let's do this first one in radians. Okay. So remember, anytime you use inverse trig, you're always trying to solve for an what? What is inverse trig used to calculate? Yeah.
An angle?
An angle. Yeah, that was my hint, and. So something that began with a vowel. So we're finding an angle. And let's try typing that in radians. So take my calculator, put it in radians. And let's do the inverse cosine of root 2 divided by 2. So you got to be careful when you type that in that you get out of the square root when you type in the divide by 2. Okay. If I write that down, is that an exact answer? 0.785, 3981, so on. No. So if I tell you you can get an exact answer in radians, then there is a way to do it. But maybe we don't want to do it in radians first. So what would be another way that we could do this problem first? Yeah?
Have it set to degrees.
Yes. Let's do it in degrees first. And let's see what happens there. Okay, we get a nice answer, 45 degrees. That is exact. Now, if we wanted to get that 0.78539, convert that by hand to radians. Okay. What do we multiply by to convert to radians? Yeah?
Pi over 180.
Pi over 180, which would turn into pi divided by 4 when we simplify it. And if you check, look at what pi divided by 4 is. 0.78539. That is the number that I wanted. All right, so if they ask you for an exact answer and it does not come out nice in radians, do it in degrees and then change to radians. All right, so let's do them all in degrees first then. And then I won't ask you for both of these answers on the test. I'm going to ask you for either degrees or radians. All right, so if we do inverse tangent of root 3 over 3, that, well, gives us 30 degrees. And what is 30 degrees the same as if we convert that to radians? Yeah?
Is it pi over 6?
Pi over 6. And those are exact answers. Okay, let's do inverse sine of 0.5. That is also 30 degrees, which is pi over 6. And let's do the inverse cosine of 1/2. Okay, 60 degrees. And what would 60 degrees be in radians? Yeah. Yep, pi over 3. Okay. If you were to try to do that in radians right away, inverse cosine of 1/2, you would get a decimal. But that's not going to be what I'm looking for. Okay, so any questions on how to evaluate an inverse trig function and get an exact answer? Yes?
Are all questions like this on the test exact, or can you get everything with the decimals?
There are some with decimals. Yeah. All right, so for the next one, it's similar to the first problem, except now they want us to evaluate and round our answer to 2 decimal places. So for this, you literally just plug it in, but make sure your calculator is in the correct mode. All right. If it's a multiple choice question, when you read the multiple choice answers, if they have the circle on them, then you know I was in degrees. If you don't see the circle, then you know I was in radians. All right. If it's not a multiple choice question, then it'll say in the directions, write your answer in degrees, or write your answer in radians. All right, so I'm in degrees, so let's do them all in degrees first. Second, inverse cosine, 0.34. second, inverse tangent, 1.46. And second, inverse sine, 0.51. Okay. And those, you know what? I'm just going to put the answers right there. Those are all your answers in degrees. All right. And well, it did say round them, so technically we should round them. So what's the inverse cosine of 0.34 to 2 decimal places? And we'll put a label on it if you need it. Yep. Go ahead. 70.12 degrees. Yep. The calculator doesn't put the degree symbol, but you know you're in degrees because you can see it up above. How about the inverse tangent of 1.46? Yep.
55.59 degrees.
59 degrees. And the inverse sine of 0.51. Yes.
30.66
Like that?
degrees.
Degrees. So the way you'll have to write it on the test, I'll either put a box like this, and I'll already have the degree symbol on the outside. If it's already there, you don't need to type it. If I give you a box and there's no degree symbol, then you have to decide if there should be one. And the way that'll work is you'll click in the box, and it'll pop up if you need it. Okay. All right, so now let's switch over and do them in radians. All right, to do it in radians, you pretty much do exactly the same thing. Put it in radians, and then type them all in again. So there's your inverse cosine, inverse sine. Where's the inverse tangent? There it is. All right. Put those right there. All right, so how about inverse cosine rounded to 2 decimal places in radians? Yeah.
1.22.
Okay, 1.22. No label because it's a radian. How about the inverse tangent of 1.46? Yeah.
0.97.
0.97. And the inverse sine of 0.51. Yes. 0.54. Okay, so that's the easiest way to do it if they ask for a decimal. Just type it in like that. All right, so for the next one, they want us to find all 6 trig functions of the angle theta. Now, a lot of people on the test get mixed up with finding a trig function of alpha or finding alpha. There's a difference. In this problem, we're finding the trig functions of alpha. We're not actually figuring out, oh, alpha is 34.6 degrees or something. That's not what we're finding in this problem. All right. So to find all these trig functions, what are we missing that we have to find first? Yep.
The hypotenuse.
Right. We've got to find the hypotenuse. Okay. How can we figure out the hypotenuse given the 2 sides that we have? Yes.
Pythagorean theorem.
Yep, we can do Pythagorean theorem. So we're going to have 36 when we square that, 25 when we square that. What's 36 plus 25? Yeah.
61.
61. And that, take the square root, and that is your hypotenuse. Okay, a couple things we want to remember. When you write your answers here, reduce the square root as much as you can. 61 doesn't reduce, so we're okay with that. But also, don't leave the square root in the bottom. Right. Okay, so let's start with the sine. What would the sine of alpha be? Final answer, no square root in the bottom. Yep.
Would it be 5 root 61 over 61?
Yep, perfect. 5 root 61 over 61. How about the cosine? Yeah.
6 root 61 over 61.
6 root 61 over 61. All right, and the tangent. 5 over 6. Okay. Once you know your sine, cosine, and tangent, what do we do with those 3 to get the other 3? Yep.
Flip them.
Yeah, we just flip them. So that one's going to be 6/5. The next one is going to be root 61 over 5. And the last one will be root 61 over 6. Okay, and that's how you find the 6 trig functions of an angle, which is not finding the angle itself. Any questions on that? All right, so next question we're going to look at involves solving a triangle. When you're solving it, it means to figure out all the sides and angles you don't know. Okay. So the first thing we want to do is, if they didn't give us a diagram, I would want to make that diagram. In this problem, they gave us a diagram. Next, what should we do in that diagram? Yeah.
Label it.
Yeah, let's put all our labels in. We could call this side A, B, C. That would make that alpha, and that would be beta. Remember, A always goes across from alpha, B always goes across from beta. All right, now let's put everything we know into a table on the side. So we know alpha is 40, and we know A is 6. We don't know B, C, or beta. Okay, and this is the 90, so of course you can put that there if you want. All right. Since each one of those things is independent, you can do any one you want first. Which one do you guys want to do first? B, C, or beta? Yeah.
Beta.
Sure. Beta is probably the easiest one. We don't really need a calculator for that. We just have to make sure all the angles add up to how much? Yep, 180. So what would beta have to be to make that happen? 50. Yep. So beta is 50. Now we can find B or C. We need to pick an angle to use as our reference. Okay, it's our perspective. Should we use the 40 or the 50? Yeah.
The 40,
Yep. How come?
because it was given.
Yeah. So let's stick with the 40 because it was given. We're also going to use the 6 because that was given. And now we can pick B or C. Let's just do B. All right. So now to find B, we need to know what position B is in and what position the 6 is in. What position is B in terms of like opposite, adjacent, hypotenuse? Yep.
Adjacent.
That is adjacent. So it's next to the angle you're trying to find. And what about the 6? Yeah,
Opposite.
that's opposite. So the trig function that we need has to have opposite and adjacent in it. There's only one trig function out of the 3 that we're using that has that. And that trig function would be
Tangent.
tangent. Tangent. Okay. Joe, what am I going to fill in for my angle? Yep, 40 degrees. So that's another thing that's important. We are using degrees. So when I go back to my calculator, I need to change back to degrees. Okay. So tangent of 40 degrees equals, and what's going to go on the other side? Yeah. Joe.
6 over B.
Yep, 6 over b. And remember the trick I showed you in class, when you end up with the variable at the bottom, you just switch the b and the tangent 40, and that gets it by itself. So b, here's that. So when you're doing a problem where you're finding trig ratios, you generally leave the answer exact. When you're doing a problem like we're doing now, we're going to round it. Okay. I'd say 2 decimal places is probably what I'm going to ask for on the test. So 6 divided by tangent 40. But before I hit enter, make sure you change back to degrees. Okay, if you forget, it's gonna come out wrong. So B is 7.15. Okay, so now we got to finish up with finding C. Could I use Pythagorean theorem to find C? Yeah?
Technically, yes, but you shouldn't.
Yeah, we could, but again, we don't want to, and we talked about why, because we're not going to use something that we found to find something else. When we start solving triangles that don't have a 90-degree angle in them, that's going to be impossible. You're going to have to use something you found to find something else, which means, unfortunately, you get one thing wrong, then you get two things wrong. But with right triangles, we can avoid that. Okay, so let's find C the same way we found B. This time we're still using the 40. We're still using the 6 because those were given. But now we want to involve C. What position is that side? Yep, that's the hypotenuse. So now, looking at the one circled in green, we want to involve opposite and hypotenuse. What trig function is that? Yeah,
Sine.
that's the sine. Okay, so how would I finish setting up my equation? Yeah.
Sine of 40 degrees, and then 6 over C.
Yep. 6 over C. It's pretty much the same setup as the last one. It's going to be 6 divided by sine 40 to get C. 6 divided by sine 40. Okay, so 9.33. Okay, now if you check a squared plus b squared, it should equal c squared. That'd be a good way to check it, but I feel pretty good with what we did there. Okay, any question on that one? Okay, so this one, same directions as the last problem, solve, but the setup is a little different because they're giving you two sides. So what does that mean we're going to have to use because we don't know any angles in this problem? Yeah?
Pythagorean theorem.
Well, okay, yeah, that's going to help us find the side we don't know. What's going to help us find the angle we don't know? I wasn't specific.
Inverse trig.
Yeah, you're going to have to use inverse trig in a problem like this. But yeah, Pythagorean theorem will give you your third side. Let's call that A, B, C, alpha, beta. So we know A and B. What is my third side going to come out to? Yeah, 5. It's a 3, 4, 5 right triangle. So if you use Pythagorean theorem, you'll get a nice answer. Okay, now, do we want to do alpha or beta first? Which one? Alpha? Okay, let's do alpha. So we definitely want to use the two pieces of information that were given. Bless you. And I circled the angle that you wanted to find. Okay, what do we need to know about the, the 3 and the 4? Something we need to know about. Yeah? Yeah, we need their position. Okay, we have a label for them, but we need to know. We need to know where they are relative to alpha. So where's the 3?
3 is the opposite.
Where's adjacent? Okay, so let's set up our trig function to find alpha. What trig function involves opposite and adjacent? Yeah.
Tangent.
Tangent. So tangent of alpha equals 3 over 4. Now this is pretty similar to a question we did earlier. You're basically going to end up with something like that. You're going to use inverse trig. how do we get rid of tangent? What function cancels out tangent?
Inverse tangent.
Yep.
Or arctangent.
Yeah, inverse or arctangent. So we're going to take the inverse tangent of what's on the left and take the inverse tangent of what's on the right. There's no multiplying at all happening in that step. Okay. So those cancel out. And now we need the inverse tangent of 3/4. And this is okay to round. Okay, you will round this to 2 decimal places. So that's 30, if you're doing degrees, 36.87. And to get beta, you would pretty much do the same thing. Okay. So any question on how you would do beta? It wouldn't be any different. The only thing that would change is your perspective, your reference. So now if your reference is up here, those two labels do not apply anymore. They're going to switch. All right, so next equation, next problem we're going to look at is an equation where we have to solve for x, and we're going to do it graphically. So if I'm going to graph this, how would I put that in on the graphing calculator to be able to get a picture that I can see? What would be my first step? Yeah.
You have to put each side of the equal sign in a different line.
Yep. So we're going to put each side of that equation, one on y1, one on y2. Doesn't matter which one. And let's say that they want to know all solutions. So I want you to represent every solution to this equation. In order to do that, you need to set your window so that it's exactly one what? Yeah?
Cycle.
Right, you need your window to be 1 cycle wide. So that requires you to know how to find the period of 2 cosine 3x. It's a cosine function. What's the formula to find the period of a cosine function? So it's 2 formulas. Tangent and cotangent use one, and all the other trig functions use the other one. Yes?
Is it 2 pi over the absolute value of b?
Yep. So 2 pi divided by, and what's b in this case?
3?
3. So that is the period. It's not the answer to the question, but it's part of what we need. Okay, it's the period. So now set your window so that it's 2 pi over 3 units wide. Right? The way I usually do it is I go from 0 to the number that I need. So just type in 2 pi over 3. We don't need to go -10 to 10 on the y. What's going to be the range of 2 cosine 3x? How high and low is that going to go? Yeah?
3, -3.
No, it's not. The range won't be -3 to 3. What's the range normally for cosine? Yeah?
-1, 1.
It's normally -1 to 1, and we've stretched it by a factor of 2. So it's going to go.
2.
It's going to go -2 to 2. So, I mean, you could zoom in a little bit. I'd say -5 to 5 is more than enough. Okay, so hit graph. And we're going to get our 2 lines. One will be blue, the other will be red. And what are we looking for? Yeah.
Where it intersects?
Yeah, where it intersects. So let's do second calc intersect. Move our cursor up here. And one answer we get is 0.44 radians. And And the other answer, second calc intersect again. Okay, just move your cursor a little bit closer. 1.66. Okay. If the question said to find all answers between 0 and 2 pi over 3, then you've done that. Those are all the answers between 0 and 2 pi over 3. But they want us to represent all the solutions. So what could I put on the end of each of them to represent them repeating forever? Yeah?
Plus I times B. I know it's different.
Like, what would you have to add to 0.44 to get the next answer, which would be right about there? You'd have to add a certain number to it to get there. Yeah?
The period?
You would add the period. So since we can add the period or subtract the period as many times as we want, what do we put here to say that? Yeah?
2 pi over 3n.
You can add any multiple of the period to the first answer and any multiple of the period to the second answer. And that's how you find all solutions. So any question on the difference between finding specific solutions in a window or all solutions? You should know both. Okay. All right, so this question, they're giving us 2 pictures. Okay, you might have 3 or 4, like on the test to match, but I'm just doing 2 here. I've given you 2 equations, y equals tangent x and y equals 0.25 tangent x. So what I want to know is which one goes with which graph, all right? And why? Anybody think they know which one the y equals tangent x is? Is it the left one or the right one? Yeah.
Is it the right?
Okay. How come?
Because it doesn't look like it's stretched, like upwards.
Okay. So these are the same window. Okay. So one of them, I'll give you a hint. One of them is regular and one of them is squished. All right. There's no stretch happening here. So one of them is just the regular and the other one would be compressed. So out of those 2, which one looks more like the regular tangent? Yeah.
The one on the left looks regular.
Yeah, the regular tangent doesn't have as sharp of a curve as that. Okay, regular tangent is a little bit smoother. Right? So that would be your regular tangent. And then if you compress that, in this case it's being compressed by a factor of 4, then it would look more squished. Okay. So just like if you had something like this, if you take and start to stretch that out, the curve doesn't look as sharp. If you start to squish it, let's see if I can. There we go. If you start squishing it vertically, then the curve starts to get so sharp it actually almost looks like it's flat in the middle, but it's not. Okay. So any questions on matching those 2 up? Okay, it'll be very obvious on the test when you see the graphs to be able to match them up. Right? There won't be like a case where, well, it could be this or it could be that. No, it'll definitely be one. All right, so for this one, they would ask you 2 things about this on the test. First, they'd ask you to make a table. So we're going to fill in our 5 x's and 5 y's, and then match it up with a sketch, kind of like the last problem. All right. First, can anyone tell me what is the 2 going to do to the graph? Yeah.
Stretch it.
Yeah. Which way? So I need kind of like a direction, yeah?
Vertical?
Vertically, yeah. So that's going to stretch it vertically. And what's the plus 3 going to do? Yeah?
Raise the function by 3 units.
Move it which way?
Raise it,
Which way is raise?
like up.
Up. So yeah, it's going to shift it up 3. So we're stretching vertically and we're shifting up 3. Both of those transformations would affect which column? The x column or the y column? It would affect the y column. That means the x's are unaffected in this problem. Nothing's happening to them. What are my original x values for sine? Yeah, Kelsey.
0, pi over 2, pi, 3 pi over 2, 2.
Okay. And while we're here, what are my original y values? I'm not going to put them in the table because they're not the final answer. But what are the originals?
0, 1, 0, negative 1, 0.
Okay. Now, since we're doing 2 transformations on the y-axis, is the order of the transformations important? What do you think? Yeah, Joe?
Yeah.
Yeah, it is important. We had a list on Monday, the order, same order we've done all year. Which transformation do we do first? The vertical stretch or the vertical shift? Yeah.
The vertical stretch.
Yep. And how are you going to apply that transformation to all our original numbers? Yeah. Okay, so we're going to start by multiplying them all by 2. That's the stretch. And then after we do that, what are we going to do to them? Yeah.
Add 3.
Add 3. Okay, so what are my new y values going to be? Yeah.
3, 5, 3, 1, 3.
So let's see. 3, 5, 3, 1, and 3. Looks good. So there's our y values. Any questions on those? Right, now the sketch. So let's do. Let's try that. So I'm going to label my x's using the table. So I'm going to have, let's go 0, pi over 2, pi, 3 pi over 2, 2 pi. And for my y's, the highest I need to go is 5, and the lowest I need to go is 1. Just barely going to work with that graph. So 0, 1, 2, 3, 4, and 5. Okay, so now plot your points. So 0, 3. We've got pi over 2, we're at 5. Pi, we are at 3. 3 pi over 2, we're at 1. And 2 pi, we are at 3. And there is your sketch. Okay. Any questions on that?